Hello, let's take a look and see how we can build a simple infinite turn chatbot using LangGraph. In a previous video, we spoke about how we can use LangGraph to build a simple two-turn chatbot. Now we will be increasing the complexity a little bit using the tools that LangGraph gives us in order to build a near infinite turn chatbot. Let's begin. So as you can see here, I am using, before we begin, let me clear everything out. So this makes it easy to see what is happening. And for those of you who may not be aware, I am using Jupyter Lab and UV. I have set up all the packages using UV. And one thing that I like to do is that I usually like to open the same notebook and have two views of the same notebook so that I can scroll up and down, because I usually like to have my state in one side of the pane, and I have my functions and other graph modifications on the other pane. This just allows me to be smooth in my workflow. So both of these are the same notebook. So let's start initializing is. Yes, I have set up all these packages using UV. I personally find them fast. You're free to use Conda, you're free to use virtual environments, even in fact, you're even free to use Docker, which I think might be a bit of an overkill. Now let us start running these. Yes, as you can see, I am initializing the LLM to use a LangChain LLM. So even though I say it's a LangChain LLM, I mean that I'm using LangChain to access a third-party hosted LLM. This LLM is not hosted on this machine, which I'm using, which is a MacBook Pro. You can use Olama to use a similar interface to run some of your models on your machine, but that might be a bit slow. Since I like using ChatGPT and I use GPT-5 Mini for a lot of my side projects, I'm using that right now. I've set the maximum tokens as 10,024. You're free to use something smaller or something higher. The one caveat is if you keep it something really small at 16, it will not ensure that your output is limited to just 16 tokens. It will cut out the tokens after 16 tokens. So even though the response may be 24, 30, 40, 50 tokens, after 16 tokens, it just cuts off. So it is not good advice to keep it as something that's small. For the sake of demonstration purposes, I've kept it at 1024. The second thing is, since we're using a third party LLM, we would need an API key. Now, I have already set up my API key, and have spoken about how we can set up the API key in a previous video. But just to recap, you can set it up using the third party provider, which is OpenAI in my case. Having obtained the API key, it's a simple matter of setting it up as an environment variable. Now it is going to be different based on which operating system you are on, but since I'm using Mac, I'm guessing this is going to be extremely similar to how it is on a Linux machine also. But I have just exported it so that it is available, exported it through the terminal so that it is always available to any program. And this is running on my personal Mac, so I don't need to worry about clashing keys. Right, so let us initialize it and a quick walkthrough about how we can go about invoking it. Now, initially, we are just passing a simple string here, as you can see. Okay, let's make this a bit bigger. So as you can see, we are passing in a simple string here, and what we are receiving from this LLM. When I say LLM, I'm talking about the LangChain interface to the actual LLM. Is we are getting something called an AI message. Now, again, just to briefly recap, there are three types of messages that we would be interested in for the sake of this tutorial. One is a system message, which contains a system prompt. The second one is the human message, which contains or which encapsulates what the human has given or what the human has queried. And the third is the AI message, which is the response that the AI gives us. Now, there are multiple arguments, multiple parameters, multiple values and variables presented within AI message. But for the sake of our tutorial, we will be only interested in the content of it. Now, we are interested in the content, and it is this, and to set up our own message, whether it is a human message or a system message, it is a simple matter of just passing in the content as a constructor when you're initializing the object. So I will give you a brief walkthrough here. So a human message demo would be human message followed by content is equal to hello world. And when we take a look at this, we have human message demo. As you can see, we have the content here. Again, we can also specify, or we can even set our own AI message. That is not something that I would recommend at this point, but it is a capability that it is wise to be aware of. Okay, let's talk about a simple chatbot. Before we begin, I just want to call out both of these are the same notebook. They're just different views. This just allows my workflow to be smoother because I don't need to keep scrolling up and down, and I am a lazy person. Now, there are two nodes that we want that we're interested in this chatbot. Since this is an infinite chatbot, we need only two things. One is the human, rather we need the human input and we need the LLM to respond. And we are separating these into two different nodes. We have covered nodes in a previous video, so you can take a look at that for a bit of an introduction to the raw basics of LangGraph. Now, all nodes in LangGraph takes an input as a state. For the sake of this tutorial, we are limiting it to just state and not something more. Now, this state is something that we have defined here, as you can see here, and it only has one key, that is messages. That is why we will be returning messages here. So this is a human input node. So all it does is it takes input from the human, wraps it up into a human message and returns it. Now, for the sake of this tutorial, let us make it more easier where we have line numbers. So we have the human input where we're using the raw Python provided tool of input. We wrap it up in human message and we return the messages. We are returning these messages because we have already defined messages as a annotated type, or rather we have annotated it with the type of list, and we have added a reducer function called add messages. The LLM response node is again fairly straightforward. We are just invoking the LLM with all the messages that exists in the state. This could be a fairly short set of messages, or it could be a really long set of messages. And since we are using LangChain as the interface, LangChain takes care of actually structuring it out into the respective format that is required by the foundational model or the LLM, and that is an abstraction that we will gladly utilize. We are just printing the response so that we as the user can see how it is, and we are returning the messages. So in a way, we are again keeping track of the state of the LLM, or keeping track of the state of the chatbot. Run this. Again, we set up, we use the graph builder, we call graph state. Now we add node, we are adding the human input node, and we are adding the LLM response node. Fairly straightforward. And now we add the edges. So we obviously start, we need a starting point, which is by default as a start. It goes to the human input. It goes from the human input back to LLM response, and then from the LLM response back to the human input. Let's compile this. Now let's visualize the graph. Now, when we see the graph here, we see that we have human input, we have LLM response, and there is a dotted line to end. Now, this dotted line to end is a bug that exists in LangGraph, which I believe they are working on a fix. So hopefully soon this will not be visible. But for those of you who are astute, you would have noticed that there is a very subtle bug that is crept into our code that we will soon be encountering. And now let's invoke the graph. Just like how we invoke the LLM, let's invoke the graph right now. We will be passing in an empty dictionary. In the previous case, we used to pass in a system message that we will be doing in the next instances. So let's invoke this. We will be talking about routing edges, conditional edges next, but for now, let's look at this. So we, as the user, we have an input, and let's say, hello, my name is Pri. We are waiting for it to get a response. It takes some time. Yes. Actually, nice to meet you. How can I help you today? Can you tell me about LangGraph in two sentences? Now, even though we say two sentences, it could be two really long sentences. Okay, I will not read this message. Now, one quick test that I personally like to use, a small verification to see if the LLM or if the agent has a decent memory or if it even has memory, is to start a conversation, get a response from the LLM, send another query, and then in your third query, you ask it about something that happened at least one query previously. So this way, we will know whether the LLM has in any way or form access to previous queries that were given. So let me ask, what is my name? And it says your name is Shri. This is good. We're happy. Now, here's a question. How do we get out of this chat? The only option right now is to manually interrupt it. So it is akin to pulling the wire out. So when Skynet rises, this is probably a step that they would want to do. Now, it is not practical for us to always kill the process or interrupt the kernel when we have a chatbot. Ideally, we would want to be able to exit gracefully. Now, LangGraph gives us two options of doing it. Now, the state remains the same, and the way of doing it is through something called a conditional edge, and the second one is something through the command tool. Now, both of these approach the same problem in two different ways. In our case, both of them are viable, but as you continue building more and more complex agents, one or the other would be better used for us. Now, we will just define the node again. The LLM node remains the same. That is not a problem. The only difference to the human node is that we are instructing the user that the user can press Q to exit. Now, this is a router. This is what I'm calling a router, but technically this is something called a conditional edge. Now, in LangGraph, nodes are where your transformations happen, and edges control how information goes from one node, or rather, which uh, is the next node where control is supposed to flow. So you go from node A to node B through an edge. Now, in this case, we have something called a conditional edge, where the edge can decide which node it needs to pass the control to. The way that it does it is it looks at the state that exists when the control goes out of that node and it enters the edge. In this case, all we're looking at is that we are looking to see if the human input only has one character and that character is Q. So let's walk through it. So we start with messages. Rather, we extract all the messages that were there in the previous state. We look at only the last message. Since we know the structure of the agent, we know that there are only two nodes. And this router, we will construct this router, or we will place this edge such that it only goes from the human node down to the LLM node or the chatbot node. There is no way that the chatbot will directly interface with the router as an outgoing node. So coming back, we get the human message. We get the content of the human message, like I had shown earlier. We use content to get access to what is something that either the LLM has written or what the human has written. So in this case, it would be human message demo content would just be hello world. And that is all we need at this point. We just want the human's input. So we take the input here and we check. If the input is Q, we directly go to end, where end is the namespace or the placeholder for the end or for the termination point of the agent. If it is not queue, if the user has actually written a query, then it goes to the node that is LLM response, which we have hard coded in this case. Let's run this router. Let's set up the graph. Again, as usual, we have two nodes. One is the human input node, the next is the LLM response. Now let us add the edges. We add the first one here, which is, all right, let us show the lines. Right, in line 1 of this cell, we add an edge that goes from start to human. The next thing is we want a conditional edge between the human router, the end state, the end node, and the LLM response node. So this edge is responsible for routing between either the end node or the LLM node. One interesting thing about this is that if you can observe, we have the router definition here and we have the edges here, and let's look at the router definition on the right pane. If you can notice, we are returning two strings here. It is either end or it is an LLM response. We have the freedom of changing this to anything that we want. However, LangGraph still needs a way of knowing which are the nodes that that the LangGraph needs to route the control to. So that is why, along with passing in the node and the edge, we also need to pass in a dictionary that maps between the output, or rather we have a mapping from the output value to the nodes that exist in the agent. There is another way where this need not be passed when you are adding a conditional edge. So when we're adding a conditional edge, we just need to add the initial input node, or rather the initial node, the function which actually acts as the router, followed by a mapping from the output of the routing function to the actual nodes that exist in the agent. So let's run this. Let's compile the graph. Let's visualize it. As you can see, this is how the graph looks. A more clean representation would be we get the human input, there is a conditional edge that splits from the node. It goes either to end or it goes to the LLM response. Now, the LLM response only goes back to the human input. So now let's invoke this and let's add in a system message here where we say you are a helpful chatbot and we are asking it to respond in only 2 sentences. Now we invoke it. Now, when invoking, you need to pass in the state. In the previous iteration of this, we pass an empty string, we pass an empty dictionary, but in this case, we will be passing in a valid dictionary which has a key of messages and which only has one item, that is the system messages. So let's run this and let's start. Hello, my name is Free. Okay, now let's see whether it is able to route to the end. We press Q and it stops. So we need not drastically go in and interrupt the kernel. Now let's run this again and have a longer conversation where we see it route between multiple nodes. Let's run this again. Hello, my name is Free. Now, because I have passed in that string, it is not a simple character of Q. So the first instance that it ran, or rather the first node that it hit, was the LLM response node where we got this message. Now let us have let's have a longer conversation. And you tell me about LangGraph and agents. It will take some time, but we will get a response. Yes, there we go. And let's quit. And there we go. It ended, no hull, no fuss. Everything worked well. Now, there's one thing that is slightly interesting in that the router only looks at the state and it routes it to the respective node. And we have each node just spitting out an output. What if we wanted each node to decide where the next node is going to be without having to explicitly define a router function? And that is where we use the command tool that is provided by LangGraph. Now, the interesting thing about command is that it requires a different set of arguments. So previously, when we were setting up the conditional edge, we was passing in these values of which nodes we wanted the router to, or rather the conditional edge to send the information to, and we had to explicitly add a mapping here which goes to either the LLM response or the end node here. Now both of them have the same name, so it might seem redundant, but there are possibilities where the outputs from the router or the conditional edge, they need not have the same value as the nodes that exist or that have been added to the graph at that point. So let's look at command and command alone right now. LangGraph will be able to parse out the respective output nodes if we're using command, if we pass in the literal here, where we tell it that the output of this node can only be either LLM response or end. In that case, we do not need to add in an explicit mapping. Now, the second thing is we do not need to explicitly add a conditional edge here. That is because the human router will be able to pass, or rather the node which is using the command tool will be able to decide what is the next node that the control needs to flow to. The third thing is that we would use command when we want to do two things at once. One is update the state, and second is pass control to a specific node based on the state. So we are combining the conditional edge and the node into one single node. Now the inputs to command is fairly simple. We have update, which basically tells us how, or rather what the state should be, what will be the new state. And the last one is go to, as in which is the next node that it has to go to. Now, mind you, these have to be the same value. There needs to be the same value in the outputs. Now, in this case, since we're going to end, we need not update any state. It can die gracefully. So in the second case, we are updating because we want to have a further conversation. So the human message is added back to the state. The LLM response still remains the same. The LLM node has not changed at all. So let's set up the graph. Let's run this. Let's add the nodes. We are just adding human input node, LLM response node. We are just adding a node, an edge from start to the human input, and we are adding an edge from LLM response back to human input. Notice in this case that we are not explicitly adding any edge from human input to either end or to the LLM response. Let's compile the graph. Let's visualize it. Yes, it looks exactly like how we wanted. Okay, may not be exactly, but you get the point. Let's invoke the graph with the system message. Hello. Tell me about LangGraph. Now, let's test it out in a slightly different way. Tell me my name. The nice thing about working with the LLM agents is that you get a response fairly quickly in seconds. previously when building machine learning models, depending on how big it is. And I know that when I had to build a few, when I had to fine tune ResNet with a fairly massive data set, it took me at least a good 45 minutes. Right, so here we have a response and we know that it is quite good. I don't know your name, so we know that there is still history happening here. There is still state management, and we want to see how it is going. So far, it has been working well, where it goes from the human node to the LLM node. Now, let's see whether it can end quickly. And it ends. It ends gracefully. And we did not have to explicitly add any edge or any sort of logic in an edge or a conditional edge to do this. We could directly utilize command. Now, command becomes useful, a whole lot more useful, when the state becomes more and more massive and when there are multiple subsystems involved. By subsystems, it could even mean multiple agent system. It could even mean you have different modules in place within the same agent itself. Now, with this, you should be able to take this code, compress it into a single .py file, and run it and have a conversation in your terminal itself. And you can have as many conversations or as many turns as you want in the conversation. Now, I will end this with one single message. Those of you who are really clever, or rather, I would say quite astute, would notice that even this has an issue. And if you figure it out, please leave it in the comment section. I would love to reply. Thank you.